Hi guys, welcome to this Blender tutorial. Today we're going to be taking a look at many of the tools used for general scene creation. This is a mini course that is directed towards beginners for Blender 3D and focuses on many of the tools that are used in object mode for general scene creation. Take a look at some of the links in the video description for videos where we go into more detail with each of these tools. To select an object in the 3D viewport, just left click. It should be surrounded by a yellowish highlight. Left click on any object you see in the viewport to select it. Alternatively, we can left click on the name of an object in the outliner panel here, and this will also select that object in the 3D viewport. To select multiple objects in the 3D viewport, hold down the Shift key and left click. This allows you to continuously add to your selection. Note that the last object that you click is going to be defined as the active object, which is different to the rest of the selection. If we were to select multiple objects in the outliner, we would select the first object, then hold Shift to select the second object. The original object would still be selected in this case. Also, if we use the Shift key here, we can only select an active object and a non-active object as part of our selection. If we were to use the Control key or Command on a Mac, we would be able to add to our selection in the outliner in a similar way to using the Shift key in the 3D viewport. Finally, there are box and circle methods of selection that allow us to more easily select what we can see in our scene. If we click and drag, we can use box select, and this will select all of the objects within that box. You can change your method of selection here in the tool shelf. Click and hold to bring up this menu, and then you can select box, circle, or lasso. If I deselect everything, and then go to circle select, we can click and drag and then add objects to our selection just by dragging our mouse. We can come back and go to select box to return to the default when we need to. To rename an object, select the object in the outliner panel. Double left click and you should be able to rename it. In this case, I'm going to rename this object as box. Alternatively, we can also rename objects in the Properties panel, which is directly underneath the outliner. If I select the light object, I can left click here where we have the name of the object and rename it however I wish. In this case, we'll call it lamp and press enter. Now if we look at the outliner, we can see that this object's name has changed as well. In this example, we have multiple box objects. We want to change the name of all of these objects at the same time. To do so, select the objects in your scene. You don't have to select all of them, but make sure you select the ones that you want to change the name for. Next, we're going to use Batch Rename. You can access Batch Rename under the Edit menu and then go Batch Rename. From here, you can choose the type of renaming such as finding and replacing, setting new names, stripping characters, or changing the case. Here, I'm going to take all of the objects named as box. I've done this ahead of time, so this is what you should see here. Find the name of the object that you want to change, and then we're going to replace it with the new name. In this case, I'm going to turn them all back to cubes. Now we're going to select OK, and if we take a look in the outliner panel, you can see that the camera and lamp objects have maintained their original names, but all of the boxes have now become cubes. The 3D cursor is located at the center of our scene, but we can manipulate its positioning. Go to the tool shelf and select the cursor icon. Now, if you click and drag with your mouse, you can reposition your 3D cursor anywhere you want. The cursor has many different use cases, but the primary use case is to define the location of newly added objects. You can get a more accurate position for your 3D cursor by using the side panel. Press the N key on your keyboard to open up the side panel, and then come down to View. Here, locate 3D cursor, and you can define the positioning on the X, Y, and Z axes. Here, I'm going to set Z to 0, Y to 4, X to 0 as well, and we'll take Y and we'll make that -4 so that it's in its own space. And now I'm going to use that as a means of adding a new object. So let's go Add, Mesh, UV Sphere, and now we've added a new object at the position of the 3D cursor. Note, however, that if you want to continue to operate in Blender as normal, you need to ensure that you turn off your cursor mode. This can be as simple as going back to box select, and that will allow you to move and drag around your scene again. To delete an object, select that object in the 3D viewport or in the outliner panel. Then you can press either the X key or the delete key. The X key is going to give you a prompt that allows you to cancel the operation if you need to. The delete key on your keyboard will not give you this prompt and will just delete the object. Here we're going to choose delete. Note that you can also delete multiple objects at the same time. You just need to ensure they're selected. In this example, we're going to use the Shift key to select these two cubes. Then we're going to press the delete key this time, and that will straight away delete both of those objects. In Blender, there are 3 methods of transform: location, rotation, and scale. Location means moving the object in 3D space. To do this, left click to select the object. Then come over to the tool shelf and activate the Move tool. This will create a gizmo that we can use. Left click in the circle area and drag. This allows us to move in 3D space, but takes into account the view in the 3D viewport. Alternatively, we can manipulate our positioning in the side panel by going to Item and then controlling the location here on the X, Y, and Z axes. We can move on the X, on the Y, and on the Z axis. Alternatively, we can also use the hotkey, which is G. G stands for grab and again allows us to move in 3 dimensions. Rotation is the second transform. We can come over to the tool shelf to activate the rotate tool. Again, we can click where the white circle is, and this will allow us to rotate in 3 dimensions. Again, this is largely focused on where we are looking at our objects from in 3D space. If we were to move the cursor into the center of this gizmo, click and drag, this would allow us to use trackball rotation, which does not take into account the view of the 3D viewport. Alternatively, we can also manipulate the rotation values here in the side panel for the X, Y, and Z axes. Finally, we can rotate using a hotkey. If we press R, we can enable rotate mode and begin to rotate based on our camera view. If we press R a second time, we can enable trackball rotation with the hotkey. Scaling is the third transform. We can activate the scale tool here in the tool shelf. We can then click and drag within the large circle and this will allow us to increase and decrease the size of our object. By the way, I'm cancelling these operations by pressing the right mouse button. In the side panel, we can once again manipulate the exact values for the X, Y, and Z axes. Finally, we can press the S key as our keyboard shortcut, and this will also allow us to scale and increase or decrease the size of our model. An alternative to the scale tool is the scale cage. Come over to the tool shelf, click and hold, and then select scale cage. This looks quite different from the other transform tools we've used. Effectively, the middle white dots allow us to scale on a single axis. The white dots that are connected to the edges of this box will allow us to scale on 2 axes. And then the corner vertices, or the corner dots, are going to allow us to scale in 3 dimensions, or 3 axes. Note that these do not always line up with the object itself. If I was to delete this object with the delete key, and then add in a different object such as the UV sphere, you can see that this object is maintaining its own shape, but the scale cage still represents the cube. This is because the scale cage will always use the bounding box, which is the maximum width, height, and depth of the object. For now, we're going to delete that. We're going to bring our 3D cursor back to the center, and then we're going to add our cube. Here, we're going to click and drag the top point of our cube. Click and drag, and it scales up on the Z axis. The opposite point at the bottom is technically called the anchor point in this scenario, but we can click and drag from the bottom to reverse the scale. So we can scale upwards on the Z axis, or we could scale down. Both have the same effect, just in different directions. This can also be done using the side ones as well, as these allow us to scale along the X and Y depending on which one we choose. We can click and drag on the edges, and this will use the adjacent edge as the anchor point. Here we're able to scale on the X and Z axes. Here we're able to scale on the Y and Z axes. If we were to click and drag from one of these corner options, we would be able to scale on all 3 axes, again using the opposite point as the anchor for the scale cage tool. This is how the scale cage tool can be used to have better control over the scaling and resizing of a model. Returning to the original transforms, we still have the ability to scale on single axes. We don't have to use the transform values within the side panel. With the move tool, for example, we have 3 coloured arrows. The blue arrow represents the Z axis. The green arrow represents the Y axis. The red arrow represents the X axis. We can click and drag on any of these 3 arrows, and that we can change the location of our object on that specific axis. The same principle applies with rotation. We can click and drag on the blue line to rotate on the Z axis. Click and drag the green line to rotate on the Y axis. Click and drag on the red line to rotate on the X axis. This also applies, of course, to scale. We have 3 squares here, or 3 cubes. Blue for the Z axis, green for the Y, X is for the red, or red is for the X. With 2 of the 3 transforms, we have the ability to move along a specific plane. A plane represents the ability to move along two axes instead of one or three. With the Move tool, we have three squares, one blue, one Y, one X. If we were to use the blue square, we would be able to move along the Z plane. This is the complete opposite to moving along the Z axis. When we use the arrow, we move up and down on the Z axis. But if we use the blue square, we use the Z plane, which is the X and Y axis, but not the Z. You can see how this works in the side panel. So we click and drag on the arrow and only the Z value changes. We click and drag on the square and the X and Y values change, but not the Z. This can also be done with the scale tool. We can click and drag on the cube to increase the scale on the Z axis, but if we want the reverse effect, we can click and drag on the square of the same colour and this will scale on the X and Y, but not the Z. Note that we cannot scale, or we cannot rotate rather, using a plane. We can only rotate either using all three axes or a single axis at a time. If you want to lock transforms from editing, then you can do so in the side panel. For example, let's say we have the Move tool active. We can see all of the arrows for our gizmo. If we come over to our Transform tab in the side panel, next to each transforms axis, we have an unlock icon. If I was to lock the Z axis location, watch what happens to the blue arrow. It disappears. We're no longer able to influence our cube on the Y axis using the Move tool. This also applies to our hotkey. If we press the G key to grab, we can only move in two directions, or two axes, X and Y. If I was to press C after pressing G, this would normally allow me to lock to the Z axis. However, even though it appears to have locked to the axis, we cannot move at all. If we unlock, press G, we can now move again. If we press C, while the grab tool is active, we can move along the Z axis. This is doable with any of the 9 transform axes: location XYZ, rotation XYZ, and scale XYZ. The one thing to note though is that if you lock a transform in the side panel, you can still manipulate that value within the side panel itself. If we click and drag on the Y axis after locking, you can see we are in fact able to edit the Y location, despite the fact that it is locked. So even though it's a bit confusing, this lock location option applies to everything but the side panel, even though it can be found within the side panel itself. In Blender, we have the ability to undo our previous actions if we require. For example, let's say I move my object across on the Y axis, but then I accidentally move my object along the Z plane instead of the X axis. In this case, I've performed an action that was not intended. What I can do is I can go to the Edit menu and select Undo, or I can use the hotkey Control and Z. On Mac, this would be Command and C. I'm going to hold down Control and press Z. This will undo the most recent action that I performed. I can use this continuously to go back in time further, depending on how many actions I have made. If you go to Edit, Preferences and then System, you can come down to Memory and Limits and change the number of undo steps. This number dictates how many times you can use Control and Z from the most updated point of your project. In addition to the ability to undo actions, we can go in the opposite direction and redo. This is typically done if we were to use the undo tool one too many times. So in our example, we moved it across the y-axis and then across the z-plane. But then we used Ctrl-Z twice, which was unintended. We can go to Edit and then select Redo, or use the hotkey Shift, Ctrl and Z. When I do this, it will cancel out the most recent undo that I had made. On top of this, we also have the access to undo history. Return to the Edit menu and go to Undo History. Here, we will have access to all of the actions that we have made up to a certain point. For example, I can go back to when we used the Delete tool, and now we no longer have access to that cube that we had just a moment ago. If I return to Undo History, it actually deletes everything that came after that point. So keep this in mind if you're going to use Undo History. Now, if I was to use the Redo tool here, we could actually begin to move through back to where we were just a moment ago. But keep in mind that this is all going to be dependent on how many undo steps you have in your preferences file. So again, if we come back to the memory and limits, we can determine how many undo steps we have access to. And also keep in mind that if we were to use the undo history to move back to a certain point, and then we were to perform a brand new action, then we would no longer be able to use the redo, because we are now on a different branch or timeline of actions performed in Blender. As you create more objects, the ability to navigate 3D space becomes more important. To navigate 3D space, hold down the middle mouse button, which should also double up as your scroll wheel. Then move your mouse. This allows you to navigate in 3D space using a point of reference. By default, that's going to be the center of the scene, where the X and Y lines, the red and green lines, are going to intersect. If we scroll up on our scroll wheel, we have the ability to zoom in towards our point of reference. If we scroll down on our scroll wheel, we can zoom out. We can also hold down Control, middle mouse button, and move our mouse to zoom in and out. This is known as dolly zoom. Another way of navigation is to pan our view. We can hold down the Shift key, then hold down the middle mouse button and move our mouse. This allows us to pan our view in different directions. Keep in mind that if we pan our view and then navigate as normal, otherwise known as orbiting, you will notice the point of reference has changed. A good technique to use is to center your point of reference on a specific object. For example, we have the object here in the center of our scene. If we press the period key on our number pad, we can snap to this object and navigate around it. If we go to the View menu, you can locate all of the different methods of navigation. For example, we can go to the Align View option here, and we can align the active camera, we can align the view, and so on. We can also determine viewpoints and general navigation. We can also frame selected. Now that is exactly what we did just a moment ago. We had an object selected and we pressed the period key on our number pad to zoom in on the selected object, and this allowed us to orbit the object as well. We can access 2D views by going to the View menu, coming down to Viewpoint, and selecting from any of these options here. For example, we can view our object from the front, or we can view our object from the bottom. In addition to accessing our 2D views from the View menu, we can also use this interactive axis in the top corner. As we move our cursor in, you'll see we have a grey circle. If we click and drag, you will be able to navigate as if orbiting your viewport. This is a good alternative if you don't have a middle mouse button on your mouse. Alternatively, we can snap to 2D views using the X, Y and Z circles, as well as the negative versions here within the axis. If I select the Z option here, we're going to view our object from a top orthographic view. If I go with the X option, we can view from the right, and if I go from the Y, we can view from either the back or the front, depending on exactly how the interactive axis is displayed. So we can use any of these to very quickly move to any of the side or front views. In addition, if you have a number pad, you can use 1 to go into front orthographic view. You can use 3 on your number pad to go into right view, and 7 to go into top view. 9 is used to reverse each of these keys. So pressing 1, then 9 takes you to the back. 3, then 9 takes you to the left. 7 and 9 takes you to the bottom. So these are all the ways in which we can access 2D views in the 3D viewport. Whenever we go into a 2D view, we are swapping our perspective view for an orthographic view. The key difference between the two is that perspective uses depth to define how large an object should look from where you're viewing it in the scene. This sense of depth is eliminated in orthographic view. To access orthographic view other than using the 2D view method, we can press the 5 key on our number pad. We can press the 5 key again to go into perspective, so we can use the number 5 key to toggle orthographic and perspective. We can also come over here to where we have this grid icon. This button does the exact same thing. It will toggle between orthographic and perspective views. The 3D viewport allows us to display various levels of information. It does this by allowing us to choose the viewport shading method. By default, we're using the solid method. This is where we can view the vertices, edges and faces of our geometry, but we cannot see the materials, textures or lighting conditions of the scene. If we come up to the top corner of the 3D viewport, there are 4 buttons. The second one, which is the active one, is for solid view. The first one is for wireframe view. This effectively eliminates the faces from our viewport, so we can only see the vertices and edges of our models. Solid view adds in the faces. The next one is material preview. If we have any textures or materials, we will be able to see them on our object in this method of viewing the 3D viewport. Finally, we have the rendered view. This will add lighting conditions to our 3D viewport. At this point, all of the information that we would want to see in our scene would become visible. But keep in mind that if you are using the Cycles render engine and you have a lot of detail on screen, using the rendered view should only be done sparingly, as it can make Blender a lot slower depending on the device that you are using. Typically, when modeling or creating 3D scenes, we recommend sticking to solid view. In Blender, we have the ability to render still images or entire animations, and this rendering is done through the camera object. If I zoom out, you should see the camera object right here. But we are going to want to preview what the camera can see, because what we see in the 3D viewport is not necessarily what's going to be rendered. In order to preview what the camera can see, come over here to these buttons and select the one that looks like a camera. This allows you to toggle to the camera view. Everything that we see within this border frame is what we would see if we were to render an image or an animation. Anything outside of this frame would not be rendered by Blender. As a little tip, you can combine this with material preview or rendered shading to get a very accurate preview of what you are likely to see when you render the image in its final form. As another tip, you can go to the View menu in the side panel, come down to View Lock, and then lock camera to view. Then, if you try to orbit your scene, you will also move the camera. So the camera's view will now match the view of the 3D viewport. This allows you to very easily position your camera before rendering. When you're done with the position, don't forget to untick this box and navigate out the camera's view. To apply a transform, first of all, open up the side panel. All of your values should look like this by default. Your location set to 0, rotation set to 0, and the scale set to 1 with the default cube. Now let's make a change to the scale of our object. We can see here that the scale value on the X, Y, and Z axes have been altered. To apply this transform, go to Object, Apply, and then choose the transform that you want to apply. In this case, we want to apply the scale. Left click and you will see first of all that the size of our cube has been maintained. If we take a look in the side panel, the dimensions remain the same, but the scale has been reverted back to 1, 1, 1. This is now the default or the original size of the cube, because we applied the scale to its new value. This also works with rotation. If we rotate on the Z-axis, we are able to change the value of the Z-axis rotation. Another way of accessing the Apply menu is to use the hotkey Ctrl-A. Hold down Ctrl and press A to bring the Apply menu into view, and then choose Rotation. Now the Z value has been reset to 0. However, the cube itself has still been rotated within our scene. Finally, we can move our object in 3D space and also apply the location. This time, however, when we do so, the geometry will remain in the same location, but the object origin will be repositioned back to the coordinates of 0, 0, 0. To clear a transform, first of all, we need to change one of these values. Again, I'm going to scale to change the X, Y, and Z values for the scale transform. Now I'm going to go to Object, Clear, and from here choose Scale. When I do this, not only does the X, Y, and Z axis for the scale revert back to 1, but the dimensions also revert back to their default values, as does the actual size of the cube. This is the difference between applying and clearing our transforms. Apply will make the new state of the object the default, while clear will not only revert the values but the object itself back to its original state. To change the positioning of your object's origin, you can come up to the Options menu in the top corner of the 3D viewport. Left click and then choose to affect only origins. Next, we're going to use the Move tool, and now when we move our object, only the object origin, which is the orange dot at the center, changes its location. The actual geometry of our model remains in the same place. You can see in the side panel that we are changing the location of the object because the transforms use the object origin as their reference point. If I now move to the rotation and turn off affect only origins, you'll notice that the behavior of the rotation changes because the object's origin is in a different position. Now, instead of just rotating in the same place, the cube rotates around the position of the origin. Another way to reposition the object's origin is to go to Object, Set Origin, and then choose from one of these options. For example, we can position the object's origin at the location of the 3D cursor. We can move the geometry to the object origin's position, or we could move the origin back to the geometry. We can also move the origin to the center of mass based on the surface area or the volume of the object. Depending on the complexity of the object, these can position the origin in different locations. For now, let's set the origin to the geometry, which resets it back to the center of our scene. The pivot point has different use cases, but the primary use case for beginners is to manipulate the transforms of multiple selected objects at the same time. Here I have 3 cubes, and I'm going to use the Shift key to select all 3. We can change the pivot point by coming up to this menu here. Left click, and we have 5 options. The default method is the median point, the median coordinate of the 3 object origins. If we wanted to, we can rotate these on the z-axis, and all 3 objects will rotate around that median point, which also happens to be the location of the original object. However, let's say we wanted to rotate them all on their own origins. We can do this by going to this menu and then choosing individual origins. Now, if we rotate on the z-axis, you can see all 3 objects remain in the same location and are rotating on their own origins. By changing the pivot point, we can change the way these transforms affect our object. Again, if I choose Active Element, this will allow me to manipulate the rotation or scale based on the active object, which is going to be the one with the yellowish highlight. If I hit R, then Z once again, this time you can see them rotating around the object origin of this cube, which is currently the active object. Proportional editing allows us to manipulate multiple objects within a defined area. For example, we only have one object selected in our scene. We can enable proportional editing by clicking on this option here. We can also determine the editing fall-off, which determines the rate at which the influence applies for objects at a distance from our selection. If I hit the G key to grab, at the moment it only seems to be affecting the single object that has been selected, but you can see a grey circle. I can scroll up to reduce the size of the circle, or I can scroll down to increase its size. Once it's large enough, you can see that it begins to have an influence on the other objects in our scene. The closer an object is to the selection, the greater the influence that proportional editing seems to have. If we make the circle really large, then the effect seems to be the same on all objects. So you can reassess the size of your circle, which changes the way proportional editing affects all of the objects that are influenced by it. You can change this fall-off within this menu. For example, you can go with a constant offset, which actually eliminates this influence and basically makes it a 0:1 ratio. So either the objects all have equal influence, which is the case for the 3 cubes and the light in this situation, or no influence at all, which is the case for the camera, which currently isn't moving. If we make it large enough, however, even the camera becomes influenced by the tool. To change the orientation used in Blender, come up to where it says Global at the center of the 3D viewport's header. Left click, and here you can change to different transform orientations. For this example, let's take a look at the difference between global and local. To best display this, I'm going to rotate our object on the Z-axis. Then I'm going to activate the Move tool. You can see at the moment the directions of the 3 arrows. This is the same as it's always been. Now let's change the transform orientation from global to local. This time you can see that the red and green arrows have been repositioned. The global transform orientation uses the X, Y and Z directions of the 3D world itself. The local orientation uses the directions of the cube or the object that is selected for the Z, X and Y axes. In other words, it actually follows the rotated values of the object. So each object has a top, a bottom, a front, a back, a left and a right. And as we manipulate the rotation, that is actually going to be maintained when using the local transform orientation. So now we can move it along its own x-axis to reposition. And this can also work with the other transforms such as the scale tool. We can use snapping to better control our transforms. Enable the snapping tool in the header bar of the 3D viewport by clicking on this icon. Then next to it, open up the snapping menu. Ensure the snap target is set to increments. Towards the bottom, have it affect the location under move, rotation and scale. If I press the G key and begin to move my object around my scene, you can see in the side panel that we are moving by increments of whole meters. For example, I can move it up 1 meter and have it sit on top of the grid. I can use the rotate tool to rotate in increments as well. This is better done if we were to lock to a single axis. For example, we can lock to the Z axis, and you can see that it's able to rotate in increments of 5 degrees. For example, we can rotate it a full 90. We can also use the scale tool to go in increments of 0.1 each time. So we can scale on the Y axis to a value of 1.5, and we can do so easily by using the snapping tool in combination with our transforms. In addition to snapping to our transforms, we also have the ability to snap to other objects. Enable the snapping tool and open the snapping menu. Here you can change the snap target. We can change to the vertex, edge or face of another object. We can snap to the center of an edge or project to the nearest face. There are many different ways in which we can use snapping to connect objects together. An easy way to demonstrate this is to snap to a vertex. Here I'm going to take our selected object and I want to snap it to the very corner of the plane beneath it. I'm going to hit G and hover until the mouse cursor is over the corner of the plane, then left click. If we orbit our view, you should be able to see that we have perfectly aligned the cube object to the very corner of this plane. If I use the G key again, I can hover over to the opposite corner and the cube will snap into place. We can join multiple objects so that it becomes a single object in Blender. To do this, I'm going to have one object selected and then select the second object by holding the Shift key and left clicking. It's important to note that whatever object you want to be the main object should be the active one. it should be highlighted yellow instead of red. I know they're technically both orange, but one looks yellow, the other looks red, so just go with the one that looks more like a yellowish orange, and that's your active object. Then go to the Object menu, and you're going to want to choose the Join option. You can also use the hotkey for it, which is Ctrl and J. When we use this tool, keep an eye on what happens in the outliner. We currently have the cube object and the plane object. Now we're going to join them together. First of all, in our 3D viewport, both objects now appear to have the same highlight. Also, if we look in our outliner panel, the cube has disappeared, and all we're left with is the plane. Effectively, we've deleted the cube object, but we have transferred its geometry, its mesh data, over to the plane object. So now, if we were to enter edit mode, we would be able to edit both the cube and the plane at the same time because they are effectively the same object. In addition to the ability to join objects together, we can also separate a single object into multiple smaller ones, and there are 3 ways in which we can do this. I have an example here where we have a single cube object, but we have 2 cubes and we have different materials for these cubes, a red material and a blue material. If I want to separate my object into smaller objects, I first of all need to go into edit mode. I'm first of all going to demonstrate the ability to separate by loose parts. Here, we're going to select everything, and then we're going to find the Separate tool. This will be located in the Mesh menu. So come down to where it says Separate, and you'll have 3 options: Selection, Material, Loose Parts. We're going to use the Loose Parts option first. So left click, and what this will do if we go back into object mode is it will separate our 2 cubes so that we now have 2 cube objects in the outliner panel. The second method is to separate by selection. Here I'm going to go back into edit mode for the main cube, and I'm going to select this front face. We can use the P key to more quickly activate the separate menu, and then we're going to choose selection. Now, if we go back into object mode, you can see we have another cube object added, but this time it's only one side of this cube. We can hit the G key to begin manipulating this one face. I can lock it to the X-axis and move it along, and you can see that it actually inherits the original origin position of the cube that it was a part of before. This is also the case with the original cube that we separated from the model. So when you are using this separate tool, keep in mind the object origin of the original model. In the case of this cube, we might want to set the origin to the geometry. The same with this face right here. So we'll go Object, Set Origin, Object, Origin to Geometry. Finally, we have the ability to separate by material. Again, we're going to select the object, move into edit mode, press the P key, and separate by material. Now, if we return to object mode, we will be able to select the blue top and manipulate it independently of the rest of the object, because it has now become its own model in Blender. Again, if you need to, make sure to set the origin to the correct position after you have used the Separate tool. The Duplicate tool allows us to create an exact replica of the selection. To use the Duplicate tool, first select the object, then go to the Object menu. From here, come down to where it says Duplicate Objects and left click. Now you'll be able to reposition the object you've just created using the Duplicate tool. it should be an exact replica of the original model. In this case, I'm going to lock it to the y-axis and move it over here. Alternatively, you can also use a hotkey. The hotkey for duplicating objects is Shift and D. So if you were to use Shift and D on an object, you would be able to create a duplicate and then you would need to position it. In this case, I'm just going to delete that second object. The alternative method for duplication is a linked duplication, which is slightly different from what we had previously done with this cube right here. Select the main object, go to the Object menu, and then come down to where it says Duplicate Linked. You can also use Alt-D as the keyboard shortcut. Left click, and we're going to reposition the new cube. Now if we take a look in the 3D viewport, it doesn't look as though there's any difference between duplication and linked duplication. If we take a look in the outliner panel, we still have 3 different objects, so they should be completely unique from each other. If we take the original duplicated object, we can go into edit mode, select the face, and then we can manipulate the geometry. It's completely independent of the other 2 objects, so it only affects itself. However, if we return to the original model, go into edit mode again, and select the top face, and then manipulate it, you can see that not only are we able to adjust the height of the cube that is selected, we are also adjusting the linked model as well. The key difference is, when we use a normal duplicate method, the new object is effectively completely independent. However, when we use a linked duplicate, we do have 2 different objects, but they are sharing what is known as the same mesh data. So 2 different objects, but they are using the same geometry. The mirror tool can be used to move geometry across a specific axis. Here we have an example where we have a cube object on the y-axis with its object origin in the center. Now I'm going to use the duplicate tool with Shift and D. This will create a duplicated object. Now I'm going to right click. That's not going to cancel the operation, it's just going to cancel the moving of the object. So now we have 2 cubes in the same location. With the duplicated object still selected, I'm going to go to Object, then Mirror. I can choose Interactive Mirror, or I can choose one of the 3 axes, either using Global Orientation or Local Orientation. For this example, I'm going to use Y Global. This is going to immediately snap my duplicated object to the same location on the y-axis, but on the other side. So here, we're using, if we take a look at the side panel, the same location, but the geometry is a specific length away. It's basically 4 meters away from the center. This second cube is also 4 meters away, but it's in the opposite direction on the y-axis. You can see here in the scale that it is actually set to -1 on the y-axis. So keep this in mind because this is going to affect many tools that you use in Blender. If we were to transfer the scale value here to 1, it would actually revert that geometry back to its original location. In the outliner panel, we have what is known as a collection, which is a place to store specific objects. If we want to add a new collection, we can do so by pressing the M key on our keyboard. This is the Move to Collection menu and allows us to move an object to a specific collection, or it allows us to add a new collection and move the object there. I'm going to choose New Collection. I'm going to give it the name Mesh for Mesh Objects, and then I'm going to select Create. If we take a look at the outliner panel, we can see that the new Mesh collection has been created. The cube object has been moved from the original collection to the new Mesh collection. I can add new objects such as a monkey object, and position it in our scene. When I do this, you will see that we have moved Suzanne, and it's also been added to the mesh collection immediately. Like objects, we have active collections, and you can see that because the mesh collection is actually highlighted with its icon. If I select the original collection and create a new object such as the UV sphere, you will see that the UV sphere has been added to the active collection, which is the top one, the original one that was created with our project. If I then want to move the UV sphere to the mesh collection, all I have to do is select it, press M, and then choose the appropriate collection from the list, in this case, mesh. Now, the sphere has been added to the mesh collection. To parent one object to another, first of all, select the object that you want to be classed as the child. Then select the object that you want to be classed as the parent. Go to the Objects menu, come down to where it says Parent, and choose from one of the following options. For the most part, you're going to just want to set this to Object for now. Now, if we choose the child object, which is the UV sphere in this case, we can grab, rotate, and scale as normal. However, you might notice a dotted line that connects these two objects together. If we choose the cube object and hit the G key to grab, both the cube and the sphere will have their locations altered. If we press the R key to rotate, you will see the sphere orbits the cube. If you hit the S key to scale, again, the sphere is influenced by the transform of the parent object. You can add multiple objects to a single parent. So we can take this Suzanne object, select the cube, and then go to Parent, Object. Now we can manipulate the cube, and this will allow us to manipulate both of the other mesh objects in our scene as well. There are many different reasons why you would want to parent one object to another. One such example is if you want the other objects to be influenced in some way by the parent object, such as if you want to orbit objects around each other. To clear a parent object, select that object, go to Object, and then Parent in the menu, and come down to where it says Clear Parent. Left click, and that will detach the child from its parent. Again, we can do this with our sphere object, go to Object as the menu, Parent, and then come down to where it says Clear Parent and left click. Now all three objects are once again independent of each other in the 3D viewport as well as the outliner panel. Modifiers allow us to very quickly edit the shape and form of our models while still in object mode. To locate your modifiers, go to the Properties panel and then come down to the Modifiers tab. The icon looks like a wrench. Left click and you'll be able to add a modifier to your selected object. If we click the Add Modifier button, we will have a variety of different menus, each of which allows us to select a certain type of modifier. For beginners, we typically use the Generate section and select one of these modifiers which focus on the structure of the mesh itself. For example, we can use the Subdivision Surface modifier to quickly add geometry to our model and smooth out the edges. We could also add a Bevel modifier which creates a bevel on all existing edges. Each of these modifiers are included in the modifier stack, and there are tools that will allow us to edit how each modifier is going to affect our object. The positioning of the modifier in the modifier stack is going to change the final output in the 3D viewport, For example, if we swap the bevel modifier with subdivision surface, we get a very different end result in the viewport. Constraints allow us to apply certain rules to our models and objects. For example, let's say we wanted our camera to always track the positioning of our cube. We can select the camera object and come to the Properties panel where we can locate the Constraints tab. Left click and then select Add Object Constraint. From here there are different ways in which we can constrain and control our object. A simple one is to use the Track To constraint. This will allow us to track our camera's view to a specific object. We can define the target here, so left click and then choose the cube object. And now if I was to take the cube and begin to move it around our scene, you can see how the camera continuously rotates its view so that it is always looking towards our cube object. Sometimes objects may require smooth shading to eliminate the visibility of the individual faces that make up the model. For example, we can take our cube object and press the right mouse button. This will bring up the context menu for our selection. Many of the tools that we've covered in this video are also accessible within this context menu. However, we want to focus on the top three. We have the opportunity to shade smooth, shade auto smooth, which takes into account the sharpness of the angles, and shade flat. By default, all objects are given flat shading. If I was to select shade smooth, the appearance of the cube looks very different. You might argue that it looks worse, and that would be a fair statement. Because we have these sharp edges, the Shade Smooth tool is trying to mask the appearance of the edges themselves, which creates this almost unnatural look. A better option for an object such as a cube would be to just shade flat or shade auto smooth, which takes into account the hard angles of the edges. A better use case would be with an object like a UV sphere, which is very spherical in nature and has a lot of faces that point in different directions. Again, right click and choose Shade Smooth. This creates a much smoother looking sphere in our 3D world. The Suzanne mesh is another example of a complex object that can apply smooth shading. We can apply smooth shading to get a relatively decent result, or we can use the auto smooth option, which gives us a sort of halfway point depending on the angles of the edges. With Shade Auto Smooth, you can come down to the operator panel and you can adjust the angle in real time. The lower this value, the more it looks like flat shading. But the greater the value, the more it looks like smooth shading. For now, I actually think the best option here is to shade smooth, and then go into the Modifiers tab and add a subdivision surface modifier to create more geometry. The more geometry you use, the better your object will look, especially with smooth shading. However, keep in mind that too much geometric density can affect the performance of Blender on your device. Some object types can be converted into other types. For example, we can take a text object and convert it into a mesh. Here, I currently have a simple text object, and if I go into edit mode, I can edit this text as if I was in Microsoft Word or writing an email. So here I can just type in Blender and then go into object mode. But what if I was ready to turn this into a mesh object? I can go to Object, then I can come down to where it says Convert, and I have several options from this list. If I choose Mesh, it does not initially look as though anything has changed. However, If I go from object mode to edit mode, you can now see that we are working with actual geometry for each letter instead of the standard ability to delete individual letters and type in a new word. There are many different combinations in which we can use the convert tool for. If I was to use Ctrl Z to undo a few times, this would take us back to our text object. Now we can go Object, go to Convert, and this time we can select Grease Pencil. If we go into Edit mode, you will see that we have converted it into points used for the Grease Pencil tool, which allows us to adopt a new workflow with our objects. To hide an object in Blender, we can go to the Objects menu and come down to where it says Show Hide. We can then choose to hide the selected objects, hide the unselected objects, or show hidden objects. For example, we can hide our cube because it's selected. Then we can return to the menu and show our hidden objects here. Alternatively, we also have hotkeys for this. So we can choose to hide selected with the H key, hide unselected with Shift H, and show hidden objects with Alt H. I'm going to use Shift and H to hide everything but my selection. I can use Alt and H to bring that back into view. If we go into the Outliner panel, you can also define the visibility of objects in both the 3D viewport and in your renders. If we toggle the eye icon next to an object's name, we can hide it from view. We can click on the same icon to bring it back to view. If we were to use the camera icon, this would disable the render, but it does not necessarily disable visibility in the 3D viewport. So the first icon is for the viewport, and the second icon is for the rendered image.